Hello ladies and gentlemen, what's up? It's Papa Bale. Welcome to the channel. And currently what we're looking at is a two-phase motor with 4 neodymium magnets at uh, 40 millimeters by 20 millimeters squared. So 40 by 40 by 20. Alright, and then the coils are 20 gauge and 16 gauge for both phases. And I believe it's a 30 gauge trigger strand. You got two SG circuits to complement the two drives. And we've minimized our wire usage. Not entirely though. I'm using the big diodes here. They don't fit in the breadboard, so they get extra jumpers. That's why there's so many wires. There's a lot less than I usually use. So here we go. We're going to go 5 volts in. .3. Here we go. And as you can see, if you haven't noticed, it is running now on 5 volts. And you see these stands? The printers that I had that made the big rings, they're not operational at the moment, so I'm printing stands for each of the coils. And that's just because when the maglev is, this is what works. This is what works, man. All the other ideas and the stuff that I have didn't funnel out, man. Didn't work. So I'm printing some stands. I think I'm gonna do. I might leave the drive the way it is, actually. If not, I'm gonna put 2 more 16 gauge coils on there for each drive, and then I'm gonna do big blue over here. I'm gonna do big blue. It's 11,500 turns, a 32 gauge, and I'll put a core in it. And then this one, which is 18,000 turns of 32 gauge with the soft iron core. Currently, I haven't put anything on top. That's the magnet right there for the maglev, the top one. Currently, I haven't needed it, and I believe it's because the magnets themselves are doing that. It's already being done. And it's cool that it works that way with everything facing north. Alright, so this is 5.3 volts with 0.0 amps. Okay, I'm going to turn it up. It's just under 100 milliamps. That's 9 volts in, 0.4 amps being drawn. I wonder how much electricity would be generated the way I do it, just from that 5 volts that we had a second ago. Crazy amount of voltage. With those 2 coils alone, it'll be sick. With this much speed and those magnets in there, just no. I mean, you can probably get better doing something else, but Nah, I mean, you're going to get about half an amp doing it that way. That's still quite a bit for 32 gauge. Alright. And we're just waiting on those stands, and then I'll be able to, hook this up so we can see it. Now the other coils that I would put on there if I did 4 generator coils is this 32 gauge coil that's 10,000 turns. So that would be about 40,000 turns of 32 gauge. And then this is 3,333 turns of 26 gauge with a soft iron core. Sweet. They're my baby Utrons. Got to remake the rotor that they're supposed to sit in. They don't sit quite right, and it's kind of bumpy, and we need to redo it. So yeah, look at this variety of coil. You try something and it works or it doesn't work. Here we go. Look at that. So 2130. It's not going very fast. About 20. It's going about 500 RPMs. I'm going to turn down the power now and try and lose all the hundreds of milliamps. We're down to 1. Alright, 5.5. 0 milliamps. Yeah, it is slowing down. So 5.5 for this motor with the Bedinis, 5.5. There we go. That just feels to me like it's about to lift off the pole, man. That was pretty dope, though. That was awesome. That was just starting to pick up speed, actually. Thinking I might put the top toroid on, and yeah, man, this is gonna be sweet when it's finished. And I'm gonna do it my way, man. I'm gonna use the SG. That's the one thing I'm gonna use that isn't my style. And we're gonna generate as much AC electricity. We might even use one of the bridge rectifiers and make it all DC. We're going to generate as much electricity as we can without actually using any bifilar coils. Alright, thank you very much. Peace out. Have a wonderful day. Bye now.